In this video here, we're going to take a look at exam revision for numerical methods. So for this video then, all we're going to do here is answer some exam style questions based on numerical methods, and as you can see then, this will cover the following topics here. So what do we have then? Well, to begin with, we have locating roots, we then have iteration, we also have the Newton-Raphson method as well as the trapezium rule, and then finally here we have modelling with numerical methods. So as always then, what I'd recommend here is that you pause the video and have a go at the questions as they appear, and then just double check that your solution matches what we get on the screen. So that should give us everything that we need here to get started. Let's begin now with question 1. So to get us started here then, let's begin with question 1. So for this question, right, as we can see here, we're just given this function. So g of x is equal to e to the x minus 2x minus 1. Now for the first part of this question here, part A, all we want to do is show that there is a root alpha in this given interval. So for part A then, so to show that there is a root alpha in this given interval here, what we need to do is consider a change of sign in the interval. Okay, and to do that then, let's start by finding g of 1.2, and we're also going to find g of 1.3. So like we just said then, let's begin here by finding g of 1.2. So g of 1.2 then, nice and straightforward, right? Just substitute 1.2 into this function here. We get e to the 1.2 minus 2 lots of 1.2 minus 1. Okay, just put this into your calculator here. And if you do this correctly then, what you should find is we get minus 0.07988, so on and so on. Okay, so on and so on there. Now, as we can see then, right, this is negative, so it's less than 0. Like so. And what we'd hope for here then, is when we find g of 1.3, we'd hope that the result then is positive, because that would indicate a change of sign in the interval. So g of 1.3 then, we get e to the 1.3 minus 2 lots of 1.3 minus 1. Again, just put this here into your calculator. And if you do this correctly then, what you should find is we get 0.06929, so on and so on. Okay. Well, this is greater than 0, so it's positive. So it's greater than 0. Perfect, because what we've got here then is a change of sign in this interval. Okay, so let's just make a note of that as well. So there is a change of sign. So there is a change of sign in the interval. So the interval then is 1.2 to 1.3. 1.2 to 1.3 there. And this function here then, g, is also continuous. Let's make a note of that as well. And g here is continuous. Continuous, UO, US, my spelling's not the best, but there we go. G is continuous. So therefore then, what does this show here? Well, this shows then that there is a root. So there is a root. And the root here then is given as alpha. So there is a root alpha in the interval. In the interval 1.2 to 1.3. Okay. 1.2 to 1.3 there. And there we have it then. So hopefully nice and straightforward just to get us started. That gives us the solution to part A. So now for part B then. Again, also nice and easy here, right? All we want to do then is find g prime of x. So all we need to do then is differentiate g of x here with respect to x. So let's just begin here by writing down g of x. So g of x here is equal to e to the x. So e to the x minus 2x minus 1. Okay, that is supposed to be an x there. Let me just redo it just so it's clear. I don't want to cause any confusion. So e to the x here minus 2x minus 1. So if we want g prime of x, all we need to do here is differentiate g of x with respect to x. And in that case then, all we need to do here is just go term by term. So if we differentiate e to the x with respect to x here, that just gives us e to the x. We get e to the x there. Now differentiate minus 2x here with respect to x. Again, nice and straightforward. We just get minus 2. Okay. And then finally the minus 1 here, well, that's a constant. And once we differentiate a constant, we just get 0. Okay. So in that case then, g prime of x here is just equal to e to the x minus 2, giving us a solution to part B. And then for the very last part of this question here, part C, it says taking x naught to be equal to 1.2 as a first approximation to alpha, apply the Newton-Raphson process once to find an approximation to alpha, giving your answer to 3 decimal places. So for part C then, all we need to do here, right, is just use the Newton-Raphson process. And don't forget then, the Newton-Raphson process, the result for that is given in your formula book, as you can see here, right? So this then is taken directly from your formula book. So to begin with then for part C, let's just note here that x naught is equal to 1.2. Okay, so if we want x1 then, so x1 here, by the Newton-Raphson process where g of x is equal to 0, because we have the function g here, so if g of x is equal to 0, then x1 by the Newton-Raphson process is equal to x naught minus g of x naught all over g prime of x naught. Okay, like so. So in that case then, x1 here, so x1 then is equal to x naught, which is 1.2. That's 1.2 minus g of 1.2 minus g of 1.2 all over g prime of 1.2. Okay. Now don't forget as well, we have already evaluated g of 1.2. We did that in part A, right? So in that case then, x1 here, nice and straightforward. So x1 here is equal to 1.2 minus, so g of 1.2 is minus 0.07988, so on and so on. So let's just write this down in full here. So minus 0.07988, so on and so on. And that's all over g prime of 1.2. So that's e to the 1.2 minus 2 here. Just use the calculator, right? And this gives us 1.32.116, so on and so on. Okay. So just put all of this here then into your calculator. And if you do this correctly then, to 3 decimal places as the question asks for, what you should get here then is 1.261. Okay. And that is to 3 decimal places there. So that gives us the solution to the very last part of this question, part C, and that gives us the solution to question 1. So let's just have a go then at the next question here, question 2. So for this question then, as we can see here, right, we have f of x, which is equal to 5x minus 2 sine x minus a, where x is in radians. Now for the first part of this question here, part A, all we want to do then is show that f of x equals 0 as a root alpha in this given interval. So to show this then, all we need to do here is just consider a change of sign in this interval. So for part A then, let's just begin here by finding f of 1.9. So f of 1.9 here, so all we need to do then is just substitute x equals 1.9 into this function here. We get 5 times 1.9 minus 2 sine of 1.9 minus 8. And all we need to do here then is just put this into our calculator. Now if we do this correctly then, what we should find here is we get minus 0.3926, so on and so on. Okay. And we can clearly see then that this is less than 0. So it's negative, right? So it's less than 0. And what we'd hope for here then is when we find f of 2 then, so f of 2 here, we'd hope that this result is positive. Okay, so let's find f of 2 then. We get 5 lots of 2 minus 2 sine of 2 minus 8. And again, all you need to do here then is just use your calculator to evaluate this. And if you do this correctly then, what we should find here is we get 0.18, 14, so on and so on. And we can clearly see then that this is greater than 0. It's positive, right? So it's greater than 0. So what this shows then is we have a change of sign. We have a change of sign. We have a change of sign in the interval So our interval here is 1.9 to 2. So 1.9 there to 2, like so. And the function f here then is also continuous. So let's also just make a note of that as well. And f here is continuous. So continuous, UO, US. So in that case then, what this shows here is we have a root. So there is a root then. In this case, alpha in the interval then of 1.9 to 2. Okay, so 1.9 to 2 there. And there we have it then. So hopefully nice and straightforward just to get us started. So that gives us the solution there to part A. So now for part B then of this question here. Let's do that underneath. It just says show that f of x equals 0 can be written as x equals p sine of x plus q, where p and q are rational numbers to be found. So basically all we need to do here then is just rearrange this equation. If we set this equal to 0, we have 5x minus 2 sine x minus 8 is equal to 0. So that's f of x equals 0. All we need to do then is just rearrange it into this form here. So basically, all we need to do then is just make x the subject here. So to begin with, let's add 2 sine x and 8 to both sides. So 5x is equal to 2 sine x plus 8, like so. And then finally here, we just want x, right? All we need to do here then is divide both sides by 5. I get 2/5. So 2/5 of sine x, that's just 0.4 sine x, plus a over 5. Plus a over 5 there. And as we can see then, in this case here, p is 2 over 5. So p is 2 over 5. And q then is a over 5. So q is a over 5 there. Okay, and there we have it then. So that gives us the solution to part B. So to finish with here then, we have part C. So for part C then it says starting with x naught equals 1.9. Use this iterative formula here with your values of p and q from part B to find the values of x1, x2 and x3, giving your answers to 3 decimal places. So for part C then, let's just do this underneath here. To begin with, let's just note then that x naught equals 1.9. So x naught then is equal to 1.9. So all we need to do here then is use iteration. So we need a little bit more room here. So we want x1, x2 and x3. And we can easily find those by using iteration. So x1 then. So x1 here would be given as, so it's p sine of x naught, but don't forget p is just 2 over 5 plus q, where q is a over 5. So altogether then, what I've got here is 2 over 5 sine of x naught plus q, where q is a over 5. Okay. And all we need to do here then is just put this into our calculator using x naught is equal to 1.9, and that would give us x1. We can then use iteration here to find x2. So x2 is equal to 2 over 5 x1, 2 over 5 sine of x1, getting carried away there, plus 8 over 5, like so. Again, we just input this here using the value of x1 that we previously found here. And then finally for x3, same idea again here. We're going to get 2 over 5 sine of x2 plus 8 over 5. Okay. Now there's two ways to go about this really. You can just do it by hand, which is absolutely fine, but it is a little bit slow and a little bit tedious. The other way then is just use a calculator. Okay. So if I grab my calculator here then, let's kind of run through this together. So the first thing that we do here then is we input x0 into our calculator. So in that case then we input 1.9 and we store that in the memory of our calculator. I do 1.9 and press enter. And what this does here then is it stores 1.9 into the memory of my calculator. And all we need to do now is input our iterative formula here and just replace xn with the answer function on our calculator, because the answer function is where we've stored 1.9. So if we do that then, what I get here is 0.4, 2 over 5 is just 0.4, so 0.4 sine of answer plus 8 over 5. So let me just quickly do that here. Made a mistake, so 1.9. I've got 0.4 sine of answer plus 8 over 5. And once you press enter here then, what this gives us is x1. And if you've done this correctly here then, what you should find for x1 is we get 1.978520035. So rounding this to 3 decimal places here, as the question asks for, what we get then is 1.979. Okay. And the magic here then is that if we press enter again, this gives us x2. So x2 here then, to 3 decimal places is 1.967. And then finally, we just press enter one more time here. This gives us x3, which if we round this to 3 decimal places, then gives us 1.969 there. Okay. And there we have it then. So that gives us x1, x2, and x3, giving us a solution to part C. And that gives us the solution to question 2. And then finally, we have the very last question, question 3. So for this question here, we're going that y is equal to the square root of 1 plus cos x. Now for the first part of this question, part A, all we want to do here is complete this table below, the values of y corresponding to x equals pi over 12 and x equals pi over 3. So for the first part of this question here, nice and easy, right? All we need to do then is just substitute x equals pi over 12 and x equals pi over 3 into this equation here. Okay. And if we do that correctly then, rounding our answers to 3 decimal places, what we should obtain here then is 1.402. And then when x equals pi over 3, you should obtain 1.225 there. Okay. And there we have it then. So that gives us the solution to part A. So now for the second part of this question here, part B, well, we're given that I is equal to the integral of the square root of 1 plus cos x with respect to x from 0 to pi over 3. So for part B, then it says use the trapezium rule. And then for the first part here, with values of y at x equals 0, pi over 6, and pi over 3 to find an approximate value for I, giving your answer to 3 decimal places. So for B part 1 then, well, all we need to do here is just use the trapezium rule. And don't forget the result for the trapezium rule is given in your formula book. So not something that you do need to memorize. I've also included it here at the bottom of the page, just so you've got it to, use as you go through the question. And basically, what we're going to do here is just use a slightly modified table here. So the only values that we want to consider here then for part B, or part 1 of B anyway, let's do that in blue, is x equals 0. That's these values here. X equals pi over 6. That's these values here. And then finally, x equals pi over 3. So that's this value here. Okay. So basically, my new table here is just these 3 columns. Okay. That's for B part 1. So in that case then, let's do this in blue here, just so you can see the difference. So I then, our integral here, will be approximately, and all we need to do now then is just use the trapezium rule here. So what is h then for this table? Well, don't forget then, h is the difference here in our x coordinates. So from 0 to pi over 6, that's just a difference of pi over 6, right? So h then is pi over 6. So what I've got here is pi over 6 because that's h, and we divide that by 2. I've got pi over 6, and we divide that by 2, like so. We now times this here by the first y value. That would be 1.414. So 1.414 there. We then add on the last y value here, which is 1.225. So plus 1.225. And then finally 2 lots of everything else, which in this case here is just this single y value of 1.366. Okay, so 2 lots then of 1.366. Okay, so at this point here, right, just put all of this here into a calculator. And if you do this correctly, obviously just make sure that you give your answer to 3 decimal places, then what we should obtain here is 1.406 there. Okay, and that is to 3 decimal places. So now for the second part of part B here, let's do that in red. So in this case here now, we're using the full table, right? So x equals 0, pi over 12, pi over 6, pi over 4, and pi over 3 to find an approximate value for I. So for part 2 then, part B, I here, the integral will be approximately. So just be careful here then. So h in this case now would be pi over 12 because we go from 0 to pi over 12. So in that case then the difference here in our x coordinates is pi over 12. So to begin with then, we have h, which is pi over 12. So pi over 12. Don't forget we divide that by 2 as well, like so. And now we times it by the following. So we have our first y value, which is 1.414 again. So 1.414 plus the last y value, which again is 1.225. So plus 1.225. And now we have 2 lots of everything else. That's 1.402, 1.366 here, and then 1.307. So let's just write that down here. So 2 lots of everything else. So I might run out of room a little bit here. Let's see if we can make it. So 1.402 plus 1.366. And then the last y value here, well, the penultimate y value, I should say, 1.307. Okay. Like so there. We'll close that as well. I've kind of run out of room here, but you get the idea. And then all you need to do here is just put this into your calculator. And if you do this correctly then, again, just make sure that you give your answer to 3 decimal places. We should get here for I. So this is the approximate value of I. We get 1.412 there. Okay, to 3 decimal places. So there we have it then, right? That gives us the solution to both parts of part B. And that gives us the solution to the very last question here, question 3. And that brings us to the end then of this video here on exam revision for numerical methods.